Welcome to our lecture online. Before we start solving parametric equations, let's first try to figure out how we evaluate parametric equations and what that even means. Well, let's say we're given two parametric equations, x equals r cosine of theta and y equals r sine of theta. So we know there's some equation involving x and y, and of course if we haven't got experience with it, we may not realize what that equation may be. But at least we're given the two parametric equations, and sometimes to figure out what the equation actually looks like, the non-parametric equation that depends on x and y, we will go ahead and solve each of these two equations independently by plugging in particular values for the variable, the one variable that's common to both x and y, which is the variable t. So we're going to plug in certain values for t. Of course, since we already know that's going to be a circle, I've put in values for the angle right here. We're going to evaluate r cosine of theta and r sine of theta and then see how that develops. If we don't have any idea at all what it looks like, then we just pick a certain number of random variables to see where things will seem to converge to. But anyway, when t is equal to 0, the cosine of 0 is 1. So for this would be the variable x, this would be the variable y. So for x we get 1 times r, which is r, and the sine of 0 is 0, so we get 0 for the y, or the r sine of t. When we change t to pi over 6, which is equivalent to an angle of 30 degrees, the cosine of that would be 0.866, so we get 0.866 times r, and for the sine that's 0.5, so we get 0.5 times r. Change the angle to 45 degrees, or pi over 4, then we get 0.707r. The same for r sine theta, we get 0.707r because the sine and the cosine, of course, are the same for 45 degrees. Pi over 3, which is 60 degrees, we get 0.5r for r cosine theta and 0.866r for r sine theta. And finally, at pi over 2, we get 0 here and we get r over there. If we then continue in that fashion, we'll see that we'll go around the edge of a circle. At pi, r cosine theta would be minus r, and r sine theta would be 0. At 3 pi over 2, this would be 0, and this would be minus r. And then we get back to 2 pi, which is the same as 0. We get r, and we get 0. If we now plug those points in on an xy axis, let's see what happens. For t equals 0, we get x equals r, and y equals 0. That's that point right here. At pi over 6, let's see here, we get 0.866r, that would be about here, and 0.5, which would be about here, so that would be the next point right there. The next point at 0.707r for both, that would be probably somewhere in the neighborhood of here. And then the next would be 0.5r and 0.866r. That would be perhaps somewhere over here. And you can see that you see the arc of a circle. Then the next point would be this point right here, 0 and r. The next point would be minus r and 0. Then would be 0 and minus r. And then we get r and 0 again. So see, when we connect all those points together, we get something that kind of looks like a circle. Of course, this was freehand drawn. But that's what we do when we say we're going to find or evaluate a parametric equation. We're going to plug in values for the variable on which all the parametric equations depend, the singular variable that ties the variables of x and y together. When we plug in the values, you can see we get a circle of radius r. That means that this represents the equation x squared plus y squared equals r squared. So we may not right away realize that when they give us a pair or a set of parametric equations, what other equation does that represent? But then when we start plugging in some values for the independent variable that makes up the parametric equations, we begin to realize, in this case it's a circle. And of course there's other examples, parabolas and other things that we'll run into when we start showing you some examples. But at least this hopefully gives you a little bit better of an idea of what a parametric equation is, or a set of parametric equations. That's how we figure it out.